Here, a question is given to us. How are the arbitrary signal represented that are applied to the input of the transistor? Assume common mode signal and differential mode signal to be VCM and VDM respectively. We know this one. Common mode signal is represented by VCM and differential mode signal is represented by VDM. And the options are given as sum of VCM and VDM, difference of VCM and VDM, sum and difference of VCM and VDM, and none of the mentioned. So let us see the question again. See here, what is the question? How are the arbitrary signal represented when they are being applied to the input of a transistor? So what we are doing here, whenever the input of a transistor, these arbitrary signals have been given, then definitely the answer is going to be, it is going to be a sum and difference of the VCM and VDM. It will be taking the sum and difference both of the VCM and VDM. Explanation C. Now in practical situation, arbitrary signal are signal that are represented as sum and difference of common mode signal and differential mode signal. So here the arbitrary signals, whenever we talk about practical scenario, it will be the sum and difference of the VCM and VDM. Now the next one. How the differential mode gain is expressed using H parameter for a single-ended output. We are having a single-ended output means what? The input can be single-ended or else it can be double-ended. Means it can be dual input or else single input can be there, but ultimately it is having only one output. For that kind of operational amplifier, here you can assume that your input of your op-amp can be anything. Your input of your op-amp can be, it can be like this. You are having an op-amp over here. I am trying to draw with respect to the MOSFETs here. So if it is a MOSFET, keep in your mind, here your input can be, you can have the two signals here. It can be dual input signal where nothing else but again you can have your another input signal here. This could be one of the your signal for your circuit, but ultimately it is given that you are going to take your output only at one particular part. This is your one output here. Okay, this one output, and ultimately you know what is this one, where the load will be represented by the resistors, or it will be the P MOSFETs if you are trying to draw the MOSFET diagram. But I'm trying to take here load as a resistor, and this is your R1, and next one is a R2. If this kind of scenario is given, it is mentioned that only H parameter of a single-ended output. Single-ended output means what? You can have here either two input signals. You can have here either two input signals, or the other condition is what? I'm trying to use other pen here. Or else among these two, V1 or V2, among these two, here anyone can be directly grounded. Anyone can be directly grounded. Either this one can be input signal, or else anyone can be directly grounded. So you can have an input of two voltages, V1 and V2, or else your output can be, one of the output can be only one output is there, and you can have two inputs or else one input where the other input will be grounded. So this is a scenario of your circuit diagram which is given to us. Now from this one we have already we have already used the H parameters in the class for deriving the outputs of this particular differential amplifier, and we have got the output of that one is, this is your second one is a correct output. We have derived the H parameters derivations for the gain and this outputs we have derived it in the class. If you want, you can go through that particular notes, and ultimately the answer will be half of HFE RC by HIE. So this could be your final output. Next one. Find common mode rejection ratio. Find the common mode rejection ratio. It means what? It is your CMRR. They are asking us to find out what is the CMRR given provided that you are having a GM. What is GM here, ma'am? GM is nothing else but it is a transconductance. Transconductance, it is a GM value. Your transconductance is been denoted by G suffix M. So it is a transconductance. Transconductance is given to us as 16. It is given as 16 mega per ohm, and Re is the emitter resistance which is connected here down. You know the circuit. I hope you know the diagram, how the diagram will be here. If this is my two transistors which are connected like this, then definitely you will be having these two emitters are been connected like this over here, and ultimately you will be having one resistor, this part which is connected to ground terminal, and this is called as your Re, and this value of Re is given to us. The value of Re is how much? That the emitter resistance is equal to 25 kilo ohm, and this is your base, gate, and base, not gate, emitter, and collector terminal of two transistors Q1 and Q2. This is your circuit diagram which they have given to us. So now we are supposed to find it out. Now we are supposed to find out CMRR. So the formula of CMRR we have seen yesterday also, but this formula is in terms of your in terms of your GM and RE. Keep in your mind always. This formula is in terms of your GM and RE. So ultimately this formula is very important. Keep in your mind. This is the formula for CMRR whenever transconductance is given to us and also the emitter resistance has been spoken about. So whenever these two terms have been spoken, then the CMRR formula will be 1 plus 2 times of GM into RE. GM into RE, just try to substitute, you'll get the answer. The answer is 58.07 dB. Excuse me, it has to be less. It's a printing mistake. Your dB should be less. Small d, capital B. It has to be small d, capital B. The notation should be small d, capital B. So kindly make that change. It is a 58.07 dB. So 58.07 dB is nothing else but your answer is a correct one. 58, approximately it is 58 dB. So the first one is a correct one. I hope is it clear to you. Is it okay?
Yes, sir.
Then the next one. If the value of CMRR, common mode rejection ratio, and common mode gain are 40 dB, 40 dB, please excuse me for this one. The unit, it is a small d, capital B, decibel. It has to be 40 dB, and common mode gain is minus 0.12 respectively. Then determine what is the differential gain. Determine the what is the differential gain. See, in the yesterday's or in the previous lecture, we have seen that CMRR is a it is a relationship between a common mode gain and the differential gain. We have seen it in the previous lecture. So now here there are options that have been given to us: 0.036, minus 1.2, 4.8, and it is 12. So now here explanation, see the explanation. First we will see the explanation, we'll go to the option. What is the CMRR ratio? The formula of your CMRR is equal to this one. This you are supposed to put it now. It is mod of ADM upon ACM. We have seen the previous lecture. It's a mod of ADM upon ACM. That value we are supposed to calculate first, and once if you calculate that one here, you will get this answer. So see now, CMR equal to log to the power of minus 1 into 20 by 40 by 20. 40 by 20, if this is the case, then it is 100 you are going to get. So ultimately, if you substitute in this formula, your answer ADM is going to be 12. Your ADM is going to be 12. So this is your correct answer. That the answer D is a correct one. So always keep in your mind, learn the formula. Formulas are so very important. Learn the formula and then apply the if dB. If you want to convert any kind of gain, into dB, apply the logarithm. Apply the logarithm for that one, that particular value will be converted into gain. So now your answer D is the correct one. So the next one, to increase the value of CMRR, which circuit is used to replace the emitter resistance RE in differential amplifier? To increase the value of CMRR, we all know what is CMRR. CMRR is a ratio, or else we can say that it is a quality factor which tells about the common mode rejection value, which tells about the common mode rejection value. Why we are concentrating on CMRR? Because we know what is a common mode. Common mode signals are nothing else but the noisy signals. So if noise signals are there in your amplifier, then definitely what happens to your amplifier? The output of your amplifier will be uh, uh, will not be as expected. The efficiency of the amplifier will not be so good. So ultimately the noise will be inculcated into our input, and that noise also will be amplified because of the amplifying nature of the amplifier. So ultimately the output also will have some noise. So our main aim of the amplifier is what? It has to reject this. It has to reject the common mode signals. What are the common mode signals here? Common mode signals are nothing else but the noise signals which are present at the input side. So now we need to make sure that our amplifier is having a very good CMRR. What does a CMRR is? It's a quality factor which will reject this common mode signals, which will reject the noise signals. The higher the value of CMRR, the better is the efficiency of the output. The output will be having less amount of noises. So the CMRR should be very good. So now see now, to increase the value of CMRR, which circuit is used to replace that emitter resistance? Just now I shown where that R is present. R is present at the two junctions of the emitters in the differential amplifier. Then which circuit is being used? The options are given to us. Constant current bias, resistor in parallel with RA, a resistor in series with RA, diode in parallel with RA. So now among this one, constant current bias circuit will be used. So the answer will be A. Because why? Because the reason why we are using the constant current bias, because this constant bias circuit will always offer extremely large resistor under AC condition. It will offer a AC condition. It will be having large resistance, thus which provide the high CMRR. See now, our circuit is here. Excuse me. Yeah, here. If this is my your transistor like this, which is having this one, and again this emitter is connected with the another transistor where it is having the emitter. This emitter is connected to the this one. Now here ultimately we will be having what? One resistor is there. One resistor is there, and always keep in mind the resistor will be which is a passive element which takes a larger amount of space in manufacturing this ICs. So they look for some alternative which is very good compared to the comparable, and which produce the same kind of working condition of an resistor. So now here R is what? It's a resistor. It has to oppose the flow of current. It has to oppose the flow of some signals into that one. So now here, instead of this RE, instead of this particular resistor, what we are trying to use? Our answer is what? The correct answer is A. How the answer is correct? Answer is A. What is this one? It's a constant current bias. Constant current bias means what? Your current in that one. Assume that between that ground and this one, there is some kind of constant bias circuit where your ground here, the current which is flowing in this one is completely constant. The I value is constant means what? What does it mean? If I is constant means what? I is not increasing. It is completely it's not variable. Means what? Resistance is more. Resistance is more. So ultimately, if your current is constant means what? If current is not varying, means resistance is more. It is nothing else but it is equivalent to the resistor which is connected over there, which is equivalent to the large resistor. So that's why you can see here now the constant current bias offers a extremely large resistor value under the AC conditions, under the alternating current conditions, thus which provides a high CMRR. Means this RE is equal to some constant current bias. Constant current bias means it will be in the, you will be having one current uh, source here. That current source has been connected in place of the RE, where the value of this one, it is a constant one. It's a constant one. Actually, see now, if this particular current source is a variable one, you'll be having one what is this arrow mark? This arrow mark across anything, ma. Let it be across your resistor. If you are having an arrow mark, means what? That particular value of the resistor is a variable. If you don't have this arrow mark, means what? The value of that resistor or the value of the any of the source is constant. So now here we are talking about the constant one. Constant one means what? Ultimately, in place of this resistor, you'll be having only one constant current source. That current source will be having a higher resistance. So ultimately, this is the answer. Correct option is A. Correct option is A. I hope it's clear to you now. Now, next one. What is the purpose of diode? What is the purpose of diode in differential amplifier with constant current circuit? Why do we use a diode over here with a constant current circuit? Let us see the options now. Total current independent on temperature. Diode is dependent on temperature. Transistor is dependent on temperature, and none of the mentioned. So now here, why we are using diode? Because we know that the diode is a unidirectional one, unidirectional device, and it is also independent of the temperature. So that ultimately the total current which is present over there will be independent of temperature. Why it is independent of temperature? Why? Because the current is not varying. When the current is not varying, then temperature also will be constant. It will be constant. Why? Because how can I say the temperature is a constant, or why the current, whenever the current is not varying, why it's a constant? Because if a current is varying, means what? The electrons are moving. The electrons are moving from one place to another place. When the electrons are moving from one place to another place, the fast movement of the electrons will cause the thermal effect. That thermal effect only we call it as a temperature. So now here the current is constant, means what? The charge carriers are also constant. Because of that, charge carriers which are not movable, this total current which is present as a constant current circuit will be completely independent on the temperature. So now see now explanation. The base emitter voltage of transistor is constant. The base emitter voltage of transistor in constant current circuit by 2.5 millivolt per degree Celsius. Thus, diode also has the same temperature. Hence, two variations cancel each other and the total current becomes independent of the temperature. So ultimately what is happening, ma? The temperature will be independent of the particular temperature. It is actually independent. It has got a space over here. It's an independent. Okay, fine. So now this answer A is a correct one. Answer A is a correct one.